Heritage, style, classic timelessness, and a power-to-weight ratio normally reserved for exotics. These are things we look for in a sports car, and after taking leave of our senses, it's precisely what we're building. After years of work, we've made great progress, but there's a problem. Things have seemingly come to a halt, and the question is, what broke our stride? This guy. The brakes. Previously, we got our electric power steering column installed thanks to a pair of snazzy brackets, and considering the space limitations we had to work with, I'm thrilled with the results. Concern was raised that under acceleration the engine might rock and contact the shaft though, which would be bad. But thankfully the polyurethane mounts we made previously are here to tell you that
ain't happening.
Okay, so me yanking on the thing isn't quite the same as 400 horsepower, but you still get the idea that there's little to no movement. Hopefully the increased noise, vibration, and harshness won't be too bad, yet it kind of is what it is, and the only thing left to do at this point is remove a bit of material on the block and manifold to allow for heat shielding. That can happen later though, as today we need to make this thing stop. We briefly covered our new master cylinder and booster setup in episode 33, but looking at it again next to the factory unit, you may wonder how it's going to fit.
That's an excellent question. See, when we began down the path of Crown Victoria and Corvette suspension, we knew we'd be left with some hefty brakes, and I mean, that's good. If they can stop a 2-ton Ford, our little car isn't going to know what hit it. Regardless, the new calipers have a lot of piston area, requiring significant fluid to actuate them. And that means we need a large master cylinder, which reduces the line pressure and requires more pedal pressure to compensate. A heavy pedal is easily solved with a more aggressive ratio, but that leads to additional travel, which in such a small car we don't have room for. So we've ended up with a booster, and traditionally, these cars don't have one.
True, there were some late 73 models that did, but it was a remote-mounted deal and only assisted the front wheels. This setup, then, is the same as a modern car, sandwiching the booster between the pedal and master, therefore assisting both front and rear circuits while keeping them separate. It just comes at the cost of a girthy unit that can't be mounted in the trunk, for example.
Obviously, squeezing this in the car is making work for ourselves, and even now, some people are still going to think that we're more than a bit feeble for wanting power brakes in the first place. Without spending this whole episode on math though, just know that this is what makes sense for a road car, which is the whole point. So where will it live?
Normally, manufacturers stick the entire thing out the front of the firewall like this, and that's fine. But in case you haven't noticed, this is not a normal car. The wheel wells move with the hood, and anything past the leading edge of the firewall will hit them. We briefly considered redesigning this situation, however, I figured 2 episodes on the hood was already plenty, so at the end of the day, that option's just out of the question. Perhaps a more logical solution then would be to follow Triumph's lead and reverse mount the unit. That would keep things free and clear, but then we'd never be able to reach the reservoir.
And sadly, even a remote reservoir is out of the question, as they require a change in height to gravity feed that we don't have. Short of sticking it on the A-pillar, I guess.
If we made the dashboard easily removable, we could access the fluid from inside the car, though agreeably that does seem awkward for routine maintenance. And at this point, I think we're missing the obvious solution. Right. Of course, I feel like an idiot now.
Well, not really. This was actually my plan all along.
And while a bit unusual, I've already designed a series of linkages to connect the pedal to the master, while keeping the parts under compression for safety, so we just need to build it. As a self-admitted overthinker though, I always have to think about whether or not I've already overthought things. And as an example, while I was planning out my design, I came across this pedal box, which I had actually seen before, and what it does is take the motion of the pedal and turn it 90 degrees to the side, so the master and booster end up living over the transmission. Hence the name.
It is very cool and would do what we need while cutting down on a lot of fabrication, but
We've already got a plan, and there's absolutely no way it's going to fit.
Then again, it just might. So of course we pulled the trigger on one, and while there's no clutch on this model, because those ones are way out of our price range, it's really not a big deal. We're going to have to modify things regardless, and this will get us started. There's no doubt it's large, and I mean even for a regular sized car, but it is ingenious, and apparently some old Dodge vans used to have something similar. Who knew our high-tech solution would come from one of those? Except, well, it's not actually solved yet, is it? So with some braces clamped to the body, let's try mocking things up. The measurements didn't lie, it's tight, but we're used to that here, and amazingly it fits. Better than I expected, and it solves all our problems. That's a win no matter how you go about things, and all we gotta do now is build some mounts. Easy. Yeah, well, okay, there may be more to it than that. At least this design improves weight distribution by moving some of the heavier parts towards the center line of the car, and although it may be small potatoes, every little bit helps. We've now got good access to the reservoir from the engine bay. The body of the Master fits beautifully alongside the power steering motor and the front of the firewall, so we'll just have to keep an eye on the height, as it is getting pretty close to hitting up there. Finessing the exact position will come in a minute though, as first part of the box is too long and right in the way of where our clutch needs to live. Good, that opens things up, and for the life of me, I don't know why this side was longer in the first place, but there you go. Can't trust nobody. Thankfully, we've got even better fitment now, and with the HVAC popped in for good measure, I think we can see ourselves through this. Even if that blower unit is living closer to the passenger side than I was hoping for. And don't be fooled by that space there. That will fill up in no time, make no mistake. Ideally, we need to leave enough space between the heater lines and the master cylinder, so it could still be removed from the booster for service, but as you probably guessed, that's not our only consideration right now. We've got to account for everything under the dash, including the wiper system, which needs to live above the HVAC and around everything else. So we dug that out of storage and popped it in to be sure. I'm reminded now just how compact and, shall we say, frail it is. In all honesty, we may need to do something about that, but for now it is fitting together, and with any luck, each part should be individually accessible, avoiding the need to pull the entire dash bar every time something needs attention. So awesome. Let's return to the pedal box. With the brake arm standing in as a substitute clutch, you can see that the side we removed earlier will need some extensions before it goes back on. Alright, that gets that sorted, but we can't reaffix the end plate just yet, as next we need to look at the pedal mounts. True, the original ones were fine, but we're adding a clutch, don't forget, and thus we're going to need a longer bolt. Much longer, in fact, for reasons that will be obvious in due course. And to accommodate this, we need holes in both ends of the box, in line with the existing ones here, so that's what I'm attempting to mark. Though it turns out even our largest half-inch drill is still too short to get a clean transfer, but no matter. We've got other issues. These factory tabs are crooked, and the remaining end has warped from welding, so any hole drilled in it will also be crooked. Perfect. I mean, at least it's not like we bought this specifically to have a good base to work from, but oh wait, yes, we did. Anyways, the side can get pulled straight with brute force, and the inner tab can just get cut off. So there. Fixed. Now, as for that new longer bolt, I'd like to take the opportunity here to upgrade its size to 5/8 of an inch diameter, because nobody wants brakes breaking. Therefore, the existing hole needs hogging out, and after a few false starts with the dead battery, I remembered I own a drill press, which accomplished the job and made me look like a weakling. The end plate needs the same treatment next, and then it's just a matter of aligning everything for the final hole, which, after being transferred to the outside face, can get brought up to size.
Well, it better be in the right spot.
A moment, please.
It's coming along then, but what's happening with the pedals?
If you guessed that we're not going to use this one, you're right. We're not. Except for reference, as the end of it has a few important features.
Notice the arm has a bushing pressed into it, which allows the unit to rotate on this inner sleeve, even though the bolt is torqued down through it. It's very simple, but necessary, so let's see how we can copy it. This is a 5/8 inch bolt. Well, just pretend it is. A 7/8 inch tube will then create that inner sleeve, and a 1.5 inch tube will be used for the top of the pedal arm. Finally, some nifty 1-inch bronze shoulder bushings will take up the gap and keep things moving.
Technically, these should all fit together, but stock dimensions aren't exact. So we need some kind of contraption to finesse the final diameters, and I think the drill, a socket, some tape, a bolt, and a file should do the job.
I call it Mini Lathe 2.0. And okay, it's not exactly micron accurate, but it's working, and that's what matters. Thankfully, we only need the first couple of inches cleaned up for this part, which will be for the clutch pedal, and after a light polish with some Scotch-Brite, you can see we're making progress. The outer diameter of the bushing is a bit large too, though, so it's chucked up next, and we can check our progress.
We're aiming for, that's about 1/4 thou under an inch, and it tapers down to about 2 thou under an inch. So that just sort of, it starts in nicely, and then it gets a little bit more stuck as it goes.
The bushing is still a bit tight on the sleeve, but as it's a softer material than the steel, a Dremel and a sanding wheel have been chosen to open this up a smidgen. Take note of that residue there. These are what's referred to as oilite bushings, and are pretty darn cool. Powdered bronze is crushed together in a process called sintering, and the somewhat porous material is then loaded with oil, making it self-lubricating. Pretty cool. Anyway, these pieces are fitting nicely together now, and the combination also slots cleanly into the outer sleeve. So it may have taken a whole afternoon, but now we've got some workable parts. Same can't be said for the length though, as 2 bushings stacked together are slightly longer than we're wanting. So let's trim one down and get us back on track. The grinder seemed a bit brutal for something so delicate, but the hacksaw isn't proving to be very accurate, so re-enter Mini Lathe 1.0, also known as the drill press, which we'll be using to part this off.
There we go. Good. Well, that worked reasonably well. Look at that. Yeah, I think I cut through.
I think you got through, yeah.
Together, we've now got the total length we need, which, to be clear, has to be slightly less than the inner sleeve I'm cutting now, so when the bolt is tightened down, the pedal will still be free to rotate. It would be great to have nice flat faces to work with, but that's just not going to happen until I get a real lathe. Thankfully though, a bit of filing has helped in that area, and we can get on with putting things together. That's all the new important rotating bits sorted out, and you may be wondering why the side for the brake is so much longer than the clutch. Honestly, until we build the pedals, you're just going to have to trust me. For now though, let's see if we can follow the example of Lotus and add some lightness. This latest piece of tubing is for the 90-degree lever part of the brake assembly, or whatever you want to call it. The factory sleeve had a lot of slop in it, and only used a tiny 3/8 inch bolt. So our new 5/8 inch replacement should be more than a worthwhile upgrade, considering all the multiplied force of the pedal will be going through it. Great then. I think it's time to mount this in the car. Alright, everything's still temporarily clamped in place, but I think you get the idea. This new bracket symbiotically ties the rear of the pedal box into the steering column mount, so the one strengthens the other. And being bolted in, we should still have decent access for servicing later. The front corners need attachment too, obviously, but when done, the box framing will be firmly tied into the pedal assembly, which in turn will be tied into the steering column, the dash bar, and the transmission tunnel. So I think it should work pretty well. In order to mount the front then, we're going to run some bolts straight into the box framing like so, which should keep things neat and let the assembly drop straight down into the footwell. We need some reference marks to ensure everything stays where we want it though, so best to take a moment now and get it all leveled and true before we proceed any further.
Just cleaned those up finally, and they're not too bad. We had to make a little hole in the backside for the step drill to fit through, but we could even weld it up later, and nonetheless sheet metal will go over it, so it's not the end of the world. But we've just put our bolts in our new pedal box, and this is the very first test just to see if I even got those holes remotely where they need to be. Yes. That is great. That's a nice snug fit in there too. So then by the time we put the beam going down the back here, it's pretty much holding itself in now. What we need to do is get some 1/8 inch plate so we can make some little pieces that'll live here. The nuts will get welded to the inside of the 1/8 inch plate, and the plate will get welded to the 1x2, just kind of like these ones here. So with all that in place though, this coming down into here, that's our pedal box in place. And pretty soon we can start working on the actual pedals themselves and get the ergonomics down pat.
Never did I imagine we'd end up with an assembly quite like this one, but the fact that it fits in there so nicely and actually adds strength, talk about mind blown. We haven't wanted to go into much math or talk about pedal ratios today, but that's all been happening behind the scenes, and I can't wait to show you what's planned. So as always, huge thanks for watching, and our utmost appreciation to the faithful patrons, donators, and subscribers who tangibly support this show. If you're interested in helping out as well, there are links in the description below. Until next time, keep building. We'll catch you later.